but I want to remember this idea of where, how we calculate shortest distance from the origin. So if this is our point, the origin, and I've got a line, yes, sorry, I am recording. How do I, what's the process to figure out the shortest distance to this line? Sorry, or Taylor? Okay, what's the process, Chase? Okay, so the first thing is this idea of a perpendicular line. So I'm going to need to come up with a perpendicular line. Now it's important that you believe this, that it makes sense that it's got to be perpendicular. That's right. If here we have I've kind of drawn what that perpendicular line segment is. You can imagine that if I shift a little bit more to the left, all of a sudden I've got a triangle, I've got a hypotenuse. And we know that hypotenuses are longer than that side. So the only possible explanation is that it's got to be the perpendicular, the line that goes and hits that line at a perpendicular. Okay. Does everyone feel comfortable that that's logical? If you were to sketch it out, it makes sense, right? Because you got to think to yourself, well, what's going to happen when you're asked to solve this sort of thing? It's got to make sense in your head. So Chase says the first thing we need to do, and you may remember we had this acronym ESL. And she says we have to find the equation of this line. So how am I going to figure out the equation of that line? I'm given that this line here, y1 is, I'm given some equation y equals mx plus b. I don't know what the equation is, but I'm given that equation. How am I going to figure out the equation of this line? Avery? Great, because I know that in order to find an equation, I need a slope and I need a point. Well, I've already got a point because I'm told it's starting at the origin. So that part's not a problem. So now I got to figure out the slope of this line. But I'm not given any information. I'm not given the equation of that line. So how am I going to calculate the slope of this line? Great, which means if this is my line 2, the slope of 2 is going to be the negative reciprocal of the slope of 1. Right? So given that I'm given the equation for line 1, that allows me to calculate the slope of line 1. And because this is perpendicular to it, it tells me that my slope has got to be the negative reciprocal. That will give me a slope and a point, which allows me to calculate the equation of this line. But that's not enough. Step 2, even though that involves maybe 3 steps, the second big idea, in order to be able to come up with the distance to this line, I have to solve for point A. How do I solve for that point A? Claire? Great. So I solve system of equations. And that can be using substitution or elimination. That will yield point A. So that will give me my origin point and my point of intersection, point O and point A. But I'm still looking to find out how far away I am to that line. So what's the third step now, Avery? Great. I'm going to calculate the length using the length equation. My length equation is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the big picture idea. You need to be able to walk anyone through that big picture idea before you get down into the nitty gritty of those problems. I mean, you think you need that phone? So now what we're going to do is we're going to step through this process. Yesterday when we did it, we stepped through starting at the origin. And the beauty of that is, of course, the one point that we're subtracting is just 0, 0. Makes the math a little bit easier. But the concept is exactly the same no matter where my point is. So today it's a repeat of yesterday's lesson, but instead of starting from the origin, it's starting from any point. But the process is exactly the same. If I switch colors and I'm now in green and I'm interested in the shortest distance from this point P to my line, it's going to be the perpendicular line. I calculate the slope of my y1. I therefore know that the perpendicular slope is going to be my m2, negative 1 over m1. Now that I've got a point, I've got this point, and I now would know my slope is, that allows me to calculate the equation of this line. Now when I solve my system of equations, I'm solving the system of equations for this line here and this line down there. That gives me this particular point. And now I'm using my length equation, and instead of subtracting 0, I'd be subtracting whatever my point P is. But it's the exact same process. So I'm going to hand you today's note.
I don't know, it's like the ad things. She's a girl. Okay, well, I knew that was You might have mentioned it already. That was a perfect shot. I just need less
Yes. Yeah, if you want, you can get it now. Okay. Quiet, please. Hands up if you want to follow along. Well, I'll just tell you learning goal. So determine the shortest distance from any point to a line, right? So it's a very easy addition from what we did yesterday, but the whole process is involved. Given that it's the same thing as yesterday, some of you may just want to process through on your own. Not a problem at all. Hands up if you want to follow along with me at the board, so I just kind of know who I'm talking to. Okay. So we're going to determine the shortest distance from the point A, 5 minus 3, to the line x minus 3y plus 12 equals 0. So Spencer, what's the shortest distance? What type of distance is it? Great. Yeah, it's the perpendicular distance. So step 1 says to graph the line L1, 3x minus 3y plus 12 equals 0, and indicate the point with its coordinates 5 minus 3. So I'm going to look for 5 minus 3. Yep, sorry. And in order to graph the individual line L1, it's often easier just to put it in the form y equals mx plus b, because that allows you to find where it crosses the y-axis, and then just to add a second point using the slope. So I'm going to rearrange my equation line 1, x minus 3y plus 12 equals 0. I'm going to add 3y to both sides. Instead of subtracting x and then subtracting 12, I'm just adding 3y to both sides. And then I'll divide both sides by 3. Give me 1/3 x plus 4. And for simplicity, I'm going to throw the y on the left-hand side. I'll just flip the equation around. Okay? It doesn't matter how you solve that equation. But once it's in the form y equals mx plus b, Mia, what can you tell me the slope is of this equation? 1/3, and the y-intercept is 4. So that's why on the graph, you can see if we go up to the y-intercept of 4, that's there, and my slope is up 1/3. That indicates what that blue line is. So I've been able to, using my slope and y-intercept, been able to come up with my blue line. I identified my point of interest, A, 5 minus 3. And so from a visual, I'm going to try to sketch the line that is perpendicular to my line of interest. That's what I've done on the graph here. Okay, and we're saying that where the perpendicular line that meets is called point B. I'm going to identify that on my graph. And so in order to calculate the distance from A to B, I need to know what B is, but I can't figure out what B is unless I can figure out the point of intersection. In order to calculate the point of intersection, I need to know the equations of both lines, and I only know the equation of one line. So I need to calculate the equation of this line. And so the two things we need to calculate an equation, right, so I'm going to need a slope, and I'm going to need a point. My point is golden. I'm putting a check mark there because I've been given my point A, 5 minus 3. All right, so in order for me to get my slope, I'm going to call my red line here, I'm going to call it linear equation 2. How do I calculate my slope of my linear equation 2? What's the process? Right? Fantastic. So I can say that my line 2 is perpendicular to line 1. So since line 2 is perpendicular to line 1, therefore, Brandon says that the slope 2 is the negative reciprocal of slope 1. Nate, what's my slope of line 1? It's 1 over 3, so my negative reciprocal becomes negative 3, or negative 3 over 1. My point is given. So now I find my equation. Samantha, do you remember the equation of equation that I used? I'm given a point and a slope. I'll get started. It's going to be y minus y1. Excellent. And remember, every time, if you write that down, it's going to help you remember it. Emma? Sure. So I got everything I need here because I've got my slope m, I got my y1 and my x1 for my point A. So this becomes y minus, again, a little bit more complicated because I'm not using 0, 0. So it's a little bit more math. Y subtract negative 3. My slope is negative 3. X subtract 5. Y subtract negative 3 becomes positive 3. Angus, what am I going to do here when I've got negative 3 times x minus 5? Great, I'm going to distribute that, giving me. Oh, but it's the yep, great. Negative 3x, negative 3 times negative 5 is plus 15. And finally, to isolate y, I subtract 3 from both sides. So remember, this is giving my line AB, which is my line 2. And that's saying my equation is y equals negative 3x plus 12. At every point in this process, it's a long process. So at every point you want to step back and go, okay, so what have I just calculated? And how does that fit in the big picture, right? You always want to be thinking about what are all the steps that you're going to need to accomplish. So at this point, I know the equation of my blue line that was given to me. And I now know the equation of my red line because we've just calculated that. I've got the equation of 2 lines. So what's that help me do? Avery? Great, allows me to solve a system of linear equations. I've got a system because I have 2 equations, and the solution to a system is where those lines intersect. And that's going to help me because that'll tell me what my point B is, and then I've got 2 points and I can calculate the length. 1. Therefore, the equation of OA is y equals negative 3x plus 12. Any questions, or are we okay to go on? Yep. Oh, yeah, hang on. That's wrong, isn't it? Yeah, this is an old note. I mean, it's taken from a previous note where O was the origin. You're right. We should be saying AB. Really good observation, Trinity. That should say the equation of the AB is y equals negative 3x plus 12. Thanks for spotting that. Okay, so we'll continue. Yeah, so as soon as you get confused, just ask. Okay, so we're going to solve the linear system. We need to find the coordinates of point B, the point of intersection, the solution to the system. We can do this by solving the linear system mathematically. And by substitution or elimination. The equations of our lines, line AB was y equals negative 3x plus 12. And line 1. So just a small point here. Line 1, we've got basically two line 1s, or two equations. We've got the original equation here, x minus 3y plus 12 equals 0. And we've got the equation that we've rearranged. It's typically better just to go back to your original equation. It's the original source, so there's not a mistake in it. Although that sort of doesn't matter, because if you've ended up making a mistake here, that's going to be carried on through with the rest of the stuff you do. But just generally speaking, we always go back to that original source. Although theoretically, you could put that in as well, and it wouldn't matter. We're going to go with the original given equation. X minus 3y plus 12 equals 0. Yes. Yep. Can you pass it out for me? Thanks. Okay. So thoughts as to which one we will use, substitution or elimination? Brandon? Yeah. Why'd you choose that, Brandon? Great. So we'll call this one equation 1, this one equation 2. And typically these problems, substitution will be the easiest to use. For substitution, it doesn't matter as long as you get y equals. Elimination, people tend to make fewer mistakes if they have the same number of terms on either side of the equal sign, though theoretically it doesn't matter. Like right now, if I were to subtract these two equations, on the left-hand side, I have x, subtract no x's, so it would become x. Negative 3y, subtract y, it would become minus 4y. 12, subtract nothing on the left-hand side is 12, equals 0, subtract negative 3x, becomes positive 3x. 0, subtract 12 is negative 12. People tend to make more mistakes that way. It's easier if all the x's are on the same side, and all the both equations have the same have x's on the same side and y's on the same side. No. Brandon? Yep. No, you can choose. All right, so we're going to solve via substitution. I'm going to sub 2 into 1. Equation 1 is x minus 3. My y has a value of negative 3x plus 12. Plus 12 equals 0. I distribute my -3. -3 times -3 is positive 9x. -3 times 12 is negative 36. Plus 12 equals 0. If I make a mistake, someone please let me know. Simplify, x plus 9x is 10x. Negative 36 plus 12 is negative 24. Equals 0. Add 24 to both sides. And then divide both sides by 10. Giving me x equals 24 over 10. Is that my final x value? Declan? Great. Simplify it to 12 over 5. I'll call that equation 3 now. And so I've got x, but I also need to calculate my y. So I'm going to now sub 3 into linear equation AB or into 2. So -3 times 12 fifths. We just multiply the numerators. 3 times 12 is 36, negative 36 over 5. And so at this point, because I'm going to have to add a whole number 12, I'm going to want to get a common denominator. I'm going to convert 12 into a fraction, multiply top and bottom by 5, giving me 60 over 5. Negative 36 plus 60, positive 24 over 5. So this was finding my point of intersection, which if we go back to our graph, I think we labeled B. My point of intersection B therefore the coordinates of point B are 12 over 5 and 24 over 5. Any questions so far? So I now have my 2 points that are of interest. The whole point of this is to be able to calculate the shortest distance. Am I okay to go on? Oh, Paige, you got a question? Okay. Okay. So when I did my 3 times 12, I got the 36 over 5. It's going to be plus 12. So I'm thinking ahead. In order to add fractions, I've got a fraction there. I have to have a common denominator. So common denominator 5, I multiply top and bottom by 5. 5 times 12 is 60. That's really like 12 over 1. 1 times 5 is 5. All right, so we've found our point. So now we need to find the length of AB. So my point B, we just calculated as 12 fifths. And 24 over 5. My point A was provided to me as 5 minus 3. Elizabeth, do you remember the equation of a line? Yeah, I'm going to go with x2 minus x1, but they would both work. X2 minus x1 squared plus. Sorry. Yep. Y2 minus y1 squared. Great. So I've got my 2 points. Again, a little bit more complicated because we're not subtracting origin of 0, 0. So it's just numerically more intense. It doesn't matter which one we choose from. 5 is greater than 12 fifths, so I'm just going to go with 5 subtract 12 fifths. That's my x coordinates, and my y coordinates got to be consistent. -3 subtract 24 over 5. What's that? Oh, sorry, I thought. Oh yeah, no, they're not fun numbers. So we've got whole numbers subtracting fractions. So we need to convert those whole numbers into fractions. So 5 is the same as 25 over 5. Subtract 12 over 5. We square that. -3 becomes -15 over 5. Subtract 24 over 5 squared. -25 subtract 12 is 13 over 5. -15 minus 24 is -39 over 5. Thirteen squared is 169. 5 squared is 25. 39 times 39. How much did you say? 1,521. That's exactly what I was going to say. Because I have my 39 tables memorized. Right, the negative disappears. Negative times a negative is a positive. $169 plus 1521. 1690. Oh yeah. So you divided by 5. What did it give you? 338. And at this point, let's just go with our calculator answer as a rounded number. What do we get? Is it 6.7 point something? $8.22, is that? Square rooted. Is that what people got? 8.22, is that, when you take the square root of that? We're able to switch into those decimals because we're giving the approximate value. The exact answer is root 338 over 5. So on an assessment, it'll ask you for an exact value or an approximate value. It's asking, or if we ask for a decimal value, that would be the approximate. So it's approximately 8.2 units. And then it's not a bad idea at all, in this case, because we actually kind of graph those results, to go back and just look, does 8 units seem about right? I know 1, 2, 3, 4, 5, 6, 7, 8. It seems like a reasonable answer given the scale of our graph. So again, in order to be able to walk through this, you have to have the big picture idea. One way of trying to remember that is this ESL acronym, where we find the equation of the shortest line. Right, you got to remember that it's perpendicular, but when we kind of sketched out, it seemed reasonable. So to find that equation, then we solve the system for the point of intersection. And then finally, we calculate the length of the line. You need that big picture idea in order to be able to solve any of these problems.